functional molded part, protected area. This is the second part within this workbench. So within the first part we addressed the added feature command, and now we're going to go to the following one, which is the protected feature. For this case study, I'm going to sketch the case study part from blank. So before we start, let's talk about the protected feature. This command allows you to, let's say, reserve a space where additional material will not be able to be created. It's important that this works within the same body. So if you're going to have a part, the protected feature will only work within the part body, the active part body. And this is useful if you want to reserve space within a part for additional components, or if that area needs to be kept open. So for the starting sketch, I'm going to select the first plane. So I'll go to Start, Mechanical Design, Functional Modeling Part. I'm going to select the first plane and I will define a sketch. The sketch has 200 millimeters horizontal and 100 vertical, so I'm going to start with a center rectangle and I will put the values, so 200 for the horizontal dimension, 100 for the vertical. And we're also going to have a radius of 10 applied to all corners. We're going to make use of the corner feature. After that I will drag a rectangle to be able to put all the radius at once. And now using the tab key, I'm going to jump in Sketch Tools and I'm going to type in 10. And we're going to see that the corner command will ask us to trim, and we're going to say yes, yes 2 times, and this will be the defined sketch. Now within the following step, we need to define the shellable prism for this. So we see that this will be again in the basic feature, even though it's the next command in line, so this shellable feature. We're going to need to use this in order to highlight the protected feature. So I'm going to click on the shellable, and for this case study part, we're going to add a dimension for the length of 200. And this is the only input for the shellable prism that we're going to define. If I'm going to expand the part body and body, we're going to see that body 1 will be the functional set. And now using the shell properties, we're going to add a thickness of 4 millimeters and we're going to remove the bottom face. So you can find the shell properties over here at the top. If you don't find this, it's under mold. You can right click anywhere on the workbench and you're going to see the mold design properties. This is the full name, so mold design properties. Since there are only two elements, it will only say mold at the top. So we're going to go with the shell properties over here. We're going to define a thickness of 4 millimeters and we're going to remove the bottom face of the shellable prism. And this will be our case study part. So it's just a simple rectangle with a shell. After that, we're going to define a new sketch in the same plane, so the X and Y plane. We're going to see that dimension will be 90 and 80, and with the same radius. And the rectangle will be all the way to the origin of the workpiece. So again, the same plane, a new sketch. I will start it like this, so that means that this point will be on the center axis. And now we're going to input the values, so 90 for the length, 80 for the vertical. And now we can add the symmetry by selecting the top edge, hold down Control, the bottom edge, and after that the horizontal axis, and we're gonna go to symmetry. And now we're just gonna add the corner, so same as before, rectangle selection. After that we're gonna type in 10, and we're gonna select yes 2 times. So this is the sketch. We see that even though the sketch is positioned on the X and Y plane, now when we're gonna go further within the next step, we're gonna define a cutout. We have the possibility to go with floor over here. So we're gonna have both the floor and the opening values that we can input. So in order to define that, we're gonna go to cutout or push, and we're gonna see that for the floor I will input 8 millimeters. If I'm gonna preview this, we're gonna have the floor defined over there. But now for the opening I will go with -20. That means that we see the opening and we see the floor, those two elements. We can also increase them with the arrows over here, but I will keep them with numeric values inputted directly over here, so 8 -20. And we can also go with a constant wall thickness, so it will see that use body thickness is set to 4 millimeters within the shell properties, and we're gonna go with that for this area. And the top will be again a protected volume, so it will be marked in red. I'm gonna click on OK. We're gonna see by default that the software will hide the cutout, but we see the resulting feature. Okay, so that's the following step. Now we're gonna need to define some sketches that will make use of this protected feature. Again, I'm gonna go to the same plane, so X and Y. Over here I can trace some shapes. As you can see, I no longer added specific constraints, mainly the shapes. So I'm gonna position a rectangle, a circle. Over here it automatically defined that constraint. If you don't want that, when you're gonna position the circle, be aware of those constraints that will define within the viewport. Okay, and I will put also an ellipse. This will be the ellipse for the cutout. So I will not constrain this, I will leave them as they are. And now I will use this sketch to define a protected feature. So this will be the protected feature. For the input values, we're gonna go again with the same 20 millimeter value for the first length. And we're gonna see that these will also be marked in red, as in areas that will not allow material to be added. Over here, if you're gonna go to display only parents, we're gonna see that those will be the sketches. Or we can expand this protected prism and we're gonna see the values. So it's similar to a normal pad. As we can see, it's a pad from Power Design known as a prism within this workbench. We can also go with a tick value. So a tick value can be either thin solid inside thickness of 5, either along the neutral fiber or outside thickness. So for example, if I'm gonna go with outside thickness, we're gonna see that we're gonna have that 5 millimeter distance. For example, with 3, you're gonna have that that limit for 3 millimeters position over there, and only that border will be protected. So the inner core will not be protected, and we're gonna have material defined over there. We can also go with outside value, so that will further expand from our initial sketch to the outside. Or we can go with neutral fiber like this. If you're not gonna have that tick value mark, just like when we define a pad, the whole profile underneath the sketch will be protected. So this will be the intended option for now. And now to verify that this protected feature works, I have the possibility to define a new sketch. For example, starting from this plane, I'm gonna trace a new sketch. I will just roughly define a sketch. I could project the existing one, but I'm gonna just roughly create a sketch like this. And now if I'm gonna go with the added feature over here, I will see that if I'm gonna hit preview, my part will only be defined starting at the top. So maybe you are wondering why I don't have material in this area. That is because when I define the cutout, that also mark it as protected. We currently have it over here hidden, but I'm gonna expand that to better visualize that. So I can go in the negative, for example, -20. And now if I'm gonna go within a section on the middle of the part, we're gonna see that this is protected as intended by this feature. But over here we don't have any material because that's from the cutout. So if I'm gonna show the cutout, we're gonna see that this whole cutout was set to be protected volume. So that also acts like a protected feature. If I'm gonna have that disabled, I'm gonna see that there will be some errors within the sketch, mainly within the order that those were created within a protected area. So keep that in mind when you're designing parts within this workbench. Okay, so that's the end. We verify the functionality feature with added prism. So within the next video, I will create a part 3 video regarding the shareable feature. Even though we already used the shareable feature, we're going to see that there are multiple ways in which we can define the shape, just like with the added feature that we discussed in the first video. Okay, so I hope that you find this video useful. I see that the video isn't getting that much attention for Catia. So for the first part, the video was published in 29 January, so that's almost a week ago. And it only has 57 views and 1 subscriber from that. So let me know in the comment section if you want me to finish this all the way up to the last part, because I saw that I defined this Solidworks video, and this has way better view time. This is also because some of you follow this video. So let me know if you want me to continue with Catia, or is Solidworks attracting more viewers within the comment section below. Again, thanks for watching. If you find this type of content useful, please consider subscribing. That will motivate me to start creating more videos. Maybe a video a day, or at 2 days, not like this, like a week within videos. Okay, see you in the next video.